Welcome friends to this 27th module of AI. Here we have already seen the knowledge representation scheme using propositional and predicate logic. We have seen the methods of inference. One method which is called backward chaining is seen. We have also seen a method called resolution in the previous module. So far so good. In fact, predicate logic is one of the best ways of representing knowledge, one of the most elegant ways of representing and inferring, and one of the finest ways to prove that what you want to prove actually. So, it is very good, but then there is some issue with there are some issues with predicate logic. One of the most important thing that because when we are building AI systems, we want to mimic humans. Remember something that we begin with. Humans tends to deal with information which is not always complete, not always precise, sometimes things which do change over a period of time. So, that kind of information to deal with is not possible to be done using plain vanilla predicate logic, and that is what we are going to talk about in this particular module. The methods to make sure how you deal with uncertainty, imprecise, incomplete, sometimes even incorrect information coming from a random source, which obviously you do not really know what's the right value. For example, when you are playing cards, you will have to assume, that the opposite player has some card X, and if it does not have, you will have to change that, alter that truthfulness of that particular statement. So, the assumptions, again you will have to deal with those assumptions. There are many other things which we are going to talk about in two modules that we will be talking about. We will be only briefing about these methods. In fact, on the other books that I referred to earlier, or the three books rather, all three of them contain a lot of additional material and a lot of other materials available on many other websites that you may refer to. But anyway, we will be talking about knowledge representation schemes which are other than predicate logic, which basically augments predicate logic for dealing with all these different types of information. And the method, the first one that we are going to begin with is called non-monotonic reasoning system. Non-monotonic means predicate logic is known to be monotonic. Monotonic means it moving in one direction. Means in predicate logic, number of facts known to be true is any point of time is always increasing, because you again going to prove new things. But once something is proven, it is never proved to be wrong. Okay. Once something is known to be true, it will always remain true. So, that is why it is called monotonic. In real world, it might not be the case. Something which is known to be true now, it again convert that to false. For example, if I say that it is day, at night my statement becomes false. Okay. So, point is this truthfulness of such statement may become false later, and it is pretty important for humans to reason with such statements. And if you want to write AI programs which can mimic humans, those programs should be able to deal with such information. So, NMRS is one such example. There is something called subjective probability. Now, when a doctor says that there is a 70% chance that you have malaria, doctor is not actually using the probability. A probability, once you say 70%, the rest of the disease must have exactly 30% probability, because the total amount of probability should always be 1. Now, that you can always say or be certain about when the doctor says that. Doctor is basically talking about his own intuition, his own judgment based on his own experience, and 70% is just a quantification of that idea. 70% is not the probability. It looks like probability, it is not. It is just the judgment of the doctor that there is a 70% chance that you have malaria. It is not probability, but it looks like probability, it is not. So, that is called subjective probability, and we will be also talking about a very brief introduction to something called certainty factor, or CF, which talks about this subjective probability. But then there are let us take some statements and see what the problem is. If you want to represent this statement in predicate logic, what the problem could be. The first statement is the atmosphere is hot now, but will be cooler in the evening. Now, this statement, if you look at it, it look quite innocuous statement, but it is pretty difficult for somebody to represent this in predicate logic, because you say that atmosphere is hot. Right now, this statement is true, but in the evening, the statement becomes false. Okay. So, very statement which is true now becomes false. How do you represent this change in truthfulness of the statement? Predicate logic does not have anything to do with this. Okay. So, this problem is solved by NMRS. We will see how that is done. The other statement, it is very well designed website. Now, this statement again, this looks quite innocuous, simple, but it is not. The word very well designed itself is called fuzzy. When I say that very well designed, I mean that I have seen 100 websites, and out of that 100 websites, this probably is top 10%. Somebody else, when there is a very well designed website, he has seen 100 websites and it is talking about top 1 or 2%. And when somebody else looks at the same site, might be talking about top 25%. So, point is, this is little vague way of telling something. There is, you need to quantify this if you want to reason from it. That is the issue. Okay. And not only that, this particular range depends on person. Okay. And the next statement makes it little more explicit. The statement says that young politician is older than an old student. Now, if you look at the predicate logic representation of the statement is always false. A young person cannot be older than old person. Okay. But here it is an interesting statement. It says that, in fact, the statement is true in the sense that young politician, the word young, with when you associate them with politician, it assumes a different range than when you associate word old with a student. For example, a 28 or 8-year-old person, if he is studying somewhere, even in postgraduate schools, you can consider him to be old, but a 32-year politician is considered to be young. Okay. The point is, when you talk about young, is a concept which carries different meaning in different context. That is the problem. How do you represent this difference in predicate logic? There is no way of doing that. Okay. So, that is the other problem. The third one, if the clothes are heavier, rinse more. Now, you can see that again this is pretty simple, innocuous looking statement, which is pretty hard unless you quantify these items. Heavier means what? 5 kgs, 7 kgs, 10 kgs, rinse more means 1 cycle, 2 cycle, 10 minutes, 20 minutes, what? You need to quantify. In fact, such statements are very good. In fact, such rules are very good because they are quite general statement, can take a huge burden off your shoulders. Otherwise, you will have to write a statement like, if the cloth weight is 4.5, rinse this much, cloth weight is 4.7, do it. You do not need to do that. In fact, this actually talks about two different ranges, a range of being heavy and range of rinse, and you need to associate this range somehow. This is what it is trying to say, but predicate logic again has no way of representing it this way or using this for reasoning in this way. So, that is the other problem with predicate logic. The other statement, South Indians are generally soft spoken. This is one statement made by one of my colleagues, and I am just keeping it here. Now, this is a general belief. Now, remember, in predicate logic, whether a statement is either true or false, but this is a statement which is generally true. When you say general belief, what does that mean? It is generally true, but it is not so that is 100% true. There you may find somebody who is not all that soft spoken, he is a South Indian, but not soft spoken, possible. Point is, this is a statement which is not 100% true. Can you represent anything in predicate logic which is not 100% true? Impossible. So, that is the problem. How do you do this? How do you manage them? We will see how NMRS handles this. This is the other one. You can safely assume that you can roam around in Ahmedabad even during night without a problem. Now, this is again quite similar to the statement that we have talked about earlier, but it is little more precise, little more explicit statement. So, what does this mean? It says that you can roam around in Ahmedabad, but that is true also without much of a trouble, but that may be false sometimes. Okay. So, it is again not 100% true statement. How will you represent that in predicate logic? No way. Okay. The other one, if the patient has high fever and stomachache, there is a suggestive evidence that there is a 70% chance that the patient has typhoid. Now, again this you can see that the statement has nothing, like statement is true, but it might be true for 70% of the patient and 30% of the patient it is false. Now, how this relative degree of this thing, truthfulness, is 70% true, how will you represent that? In predicate logic is binary, 0, 1, false, true, nothing else. Here it is 70%, something in between. So, that is hard. The other one, more than 80% of road accidents, the victims are pedestrians. Now, again this statement is true for 80% of the cases, it is not true for 20% of the cases. The same problem with the representation of predicate logic. What is the difference between this one and the previous one? Remember, the previous one is based on subjective probability that we have talked about. This 70%, the value is basically a quantification of experts' judgment. Here the 80% usually, I believe that it is done this way. It has taken some statistical information available and used that statistical information to derive this information. So, this is a different thing than the earlier one. This 80% means there may be n number of accidents, and when n is equated to 100, the accidents where pedestrians are affected are coming out to be 80%, that the statistics says so, and that is represented here. In the previous case, there is almost nothing to do with statistics, is basically quantification of experts' views. Okay. So, that is the difference. Okay. These two things are little different, and we will see the how one can try solving problems using these representations. We will begin with non-monotonic reasoning system. The first example says that it is sunny, if it is raining one must use umbrella, if it is raining it is not sunny, if it is sunny you can take goggles, and Ramji is going out. And if you ask a question, should Ramji use umbrella? No, it is sunny, you know it is already sunny, what is the point? But remember, we are dealing with non-monotonic reasoning system which changes the truthfulness of something sometimes. So, we have a new fact coming in, it is raining. Okay, it started raining. So, the new fact coming in, it is raining. Now, the statement that we had in our database, it is sunny, it is raining, this, that, what is to that has to do something. Okay, so NMRS does what? When it comes, it is raining, we will try to see if this particular statement I can immediately add this thing to database, or if the statement is going to have some contradiction with somewhere. So, it will find that it is contradicting with it is sunny. How it found? Okay, we will not talk about that right now, but when it says that it is raining, it has a contradiction where it is sunny. So, both the statements cannot be true at the same point of time. So, that is why it is called contradiction. So, it stores that information in the database that 1 and 6 are contradiction. Once it adds that, it will find out which statement is older, 1 is older. So, it takes it out. So, now it is no longer sunny. So, that is the first thing that it does. Not only that, it also does something else. For example, there are 2 more statements, 8 and 9. One statement says that Ramji should wear goggles, the other one says Ramji should take umbrella. So, when one was inside, it was inside, because that depends, wear goggles depends on sunny. So, if it is sunny you should wear goggles. So, that was there inside. As soon as it goes out, Ramji should wear goggles also goes out with it, and as soon as raining comes in, Ramji should take umbrella also comes in. Now, let us try to understand it. So, the single entry have a cascading effect, single exit also have a cascading effect. We are talking about a very simple example where we only have one statement which comes in and one statement which goes out, but sometimes you will have plenty of statements to go out when with just one change. So, it has a huge cascading effect sometimes. So, you need a very good database and very fast processing for managing NMRS in true sense. What is the basis of non-monotonic reasoning? In fact, human experts is basically representing human experts. When you are talking about human experts have 2 types of knowledge. One is premise, known to be true. For example, Ramji is man. Now, that is something not going to change. Okay. The second one, it is sunny. Now, that is an assumption. Normally, it is sunny. So, it is sunny. Okay. It is default assumption. That might be false sometime. It is day. So, those are called default assumptions. They are true. Otherwise, unless you know anything to the contrary, they are true. But then if something that contrary becomes true, those statements which are true now becomes false. Okay. So, there are 2 things, premises which are true and will not change to false. The other ones, default assumptions which are true now, but may become false, and that is where this becomes non-monotonic. Number of facts known to be true may decrease as well. What are the problems NMRS is attempting to address? It addresses incomplete information problem. Whenever the information is incomplete, we can continue with whatever information that we have, and we can continue exploring it further, inferring it further. When you come to know that something which we assume true is false now, we can just revoke those things which depend on that and change everything. So, that is the second. The other one is conditions changes over a period of time. It was an earlier day, it becomes night later. It was sunny earlier, become raining and so on and so forth. The conditions do vary and it change. And sometimes when you do not know, for example, if I am trying to, it is called when you represent numbers by characters. For example, cross plus roads equal to danger. Now, you like to identify what are the values represented by these characters. Now, in this case, you can assume when you do not really know, you can start assumption, assume d equal to 1 and start and so on and so forth, or 0 and start. So, those are called default assumption or guess. So, when you do not, or when you are playing game of cards, you can see that you cannot proceed further unless you have some guess, good guess that might prove wrong later. And the other one which is very important for NMRS, because NMRS human experts also work that way. For example, if you want to hire a car and you get the car, you assume that the driver is competent to drive, you also assume that car is in working condition, the the tires are not punctured and so on and so forth, and the car has enough fuel to carry you to the place where you want to go, and so on and so forth. So, point is, you assume everything and you start going further. If you come to know that something is wrong somewhere, fine, you change your this thing, but otherwise you assume it. So, that is called circumscription. So, that is the other thing on which NMRS is based. Human reasoners, human experts usually work like this. So, NMRS is designed that way. And this is also called dependency driven reasoning. So, whenever something becomes false, everything resting on that is taken out. When a new fact comes in, everything resting on that comes in. Okay, that is called dependency driven reasoning. Sometimes dependency driven backtracking also is applied, but again I am not going to discuss how that is done, because you know when there are multiple options. Remember, we have talked about backtracking. You try first option, then you try the second one, you try the third one, you systematically try all of them. When you come to a dead end, you go to the next one. Now, usually you go in a blind fashion, okay, you try all possible combinations. In dependency driven backtracking, you choose one which is based on the dependency and not the other one. Anyway, I am not going to discuss that, as I said earlier, because we are only going to discuss about NMRS in a little brief, but the references that we had has enough information about that. The power of NMRS, the requirement of NMRS is to make sure that the statement remains consistent. Okay, so that is important. So, whenever it is raining coming in, at the Ramji should, where Google should go out. Okay. So, that is called maintaining consistency. So, there are two lists, one is called in list, the other is called out list. In list contains statements which are currently known to be true. Out list contains statements which were once upon a time were true, but now they have become false. Now, out list is going to serve two important purposes. One, they have gone out, but they might come in later. For example, it is sunny, it has gone out, but when it stops raining, the sunny may come inside. So, that is the first requirement. And second important requirement is, if you want to disprove something, remember, pure predicate logic, you cannot have any false statement. So, it is impossible to disprove anything in true sense. When you cannot prove anything, you can assume it to be false, but as I said, you cannot say that thing for sure. In NMRS, if something in the out list, you can pretty sure you can say that it is false right now. Okay, if it is raining, it is sunny there on the out list, and if somebody wants to prove that it is not sunny, you can easily do that because it is there in the out list. Now, that is the power of the additional power of NMRS. And there is a contrived example from a movie called Hina, which I seen years before, and you can see that Rishi found himself on a bank of a river, and the river is flowing back westwards, and so there is a barren land and a lot of hills around with canopy of snow and all that. He belongs to Delhi, and the default assumption that he is in India, and the only river which flows westwards is Brahmaputra. So, he assumed that I am on the bank of the river Brahmaputra, and so he is thinking that yes, I am in Assam, so I will have to start traveling eastwards because I belong to Delhi, I will have to reach Delhi. You can see that there are huge number of statements probably will come. I have not written all of them, but you can think that for reasoning this traveling eastwards, he has probably processed a lot of statements. Then he come across one more fact. He finds some signboards written in Urdu. When he finds signboards written in Urdu, he realized that there is something wrong, because the predominant language of Assam is Assamese, and if he is in Assam, the signboards should be in Assamese. And he also has the knowledge that Pakistan default the predominant language of Pakistan is Urdu. So, he understands that now I am in Pakistan. So, his default assumption that I am in India changes to I am in Pakistan. It changes everything. In fact, instead of traveling eastwards, it is traveling westwards. Okay, sorry, the other way around, the traveling westwards is to start traveling eastwards. So, that is what he should do. The complete reasoning, the single fact changes, has a huge cascading effect. Okay. So, that is something that is a problem with NMRS. In fact, if you want to really implement NMRS, this is one thing which is needed. You will have to keep that thing information, remember that dependency information. When he is in India and you derived all that, everything becomes false in a single shot, because now he is not in India, he is in Pakistan. Most of the things that he has reasoned, he has concluded, are all proven false now. Okay, so that is important here, and that is why I call the power of NMRS is not without cost. There is a cost involved. This maintenance takes a lot of time, lot of efforts, and you need good database and powerful server to do all this. The uncertainty, that is the second part of this thing. This is we are done with NMRS. Uncertainty and related issues. We will be talking about them. Remember, we need to represent, and we have talked about this. For example, 50% of population support XYZ political party, or 90% Indians are mad after cricket, more than 80% believe in God, and so on and so forth. So, this is one way, this is something that we have. Now, how this uncertainty is introduced when the actual domain that we want to study is little too big. For example, if I want to learn about the preferences of employees in India, I cannot go and interview every employee. I can just take a sample and get my solution, get my results out of it. However hard I try, what I get is only an assumption. I cannot get the right value. This is where the first case, the uncertainty is introduced, or the expert says that there is a 70% chance of having malaria or something, or the data itself introduces certainty. For example, if you take an experiment where the results are not 100% conclusive on something, or we do not have complete information, like in NMRS, when we do not have complete information, we will not be able to tell anything for certain. Statistical reasoning and probability is one of the most common methods of dealing with uncertainty, and this thing is studied in detail. It has solid mathematical foundation, and it is being used in many systems. Okay. There are some prerequisites to understand probability. We will go through this in a very brief. PE is a probability of an event E. The probability of anything is always between 0 and 1, and sum of the probability is always 1. An outcome is one of the results. For example, if you draw a deck, one card from deck of cards, getting an ace is an example of an outcome. And one more simple things, there are two possible events. For example, one is the card that you draw is an ace, and second is the card that you draw is black. These are two events, and what is the probability of having occurring them together? Simple multiplication of both of them. If you draw a black, it is 13 out of 54. So, that is 1 4, and black ace is 1 out of 4, 4 out of 54. Okay, so that is 1 upon 13. So, when you multiply that, what you get is 1 upon 54, and again black ace is 1 upon 54. So, you can see that is how it is done. Okay. One very useful formula which is used in expert systems is called Bayes formula. This Bayes formula is a very good method of determining something based on statistical reasoning. For example, if I am talking about a character recognition system, if I pick up a character and I notice a few things about that character. For example, there is I observe a vertical line, I observe a dot, I observe a horizontal line. Now, these are called evidences. So, based on these evidences, what is the probability of a character being A or B or C or what? So, if I want to get that Bayes formula is quite useful. So, for that particular formula, BI is a particular belief. That means there are 20. For example, let us assume that we are only talking about lowercase letters. So, we have 26 beliefs. The first belief is the character is small a, second is small b, and so on. So, that is 26 beliefs. And when I say that P BI and when BI is the character is a, it means that what is the probability that this particular character is a. Okay. P BI slash E is when the event E happens, what is the probability that this particular the character. For example, when I observe the horizontal line, what is the probability that the character is A? P E B I is exactly opposite. P E B I is that when that event is certain, when the character is A, what is the probability that you get that horizontal line? You can say that for capital A, horizontal line will surely be observed. But in case of G, that horizontal line may not be present, especially when you talk about recognizing handwritten characters. And K is total number of beliefs, that is called, in our case it is total 26, and the formula is shown on the table. P BI slash E is whenever there is an evidence about something, the probability of BI is what? It is shown on the screen. And what this Bayes formula is going to give us is gives us the probability when that event happens. And there is an important one called a priori probability, which I have not talked about. A priori probability which is used here is without any evidence, what is the probability that the character is A? In English, you can see that not all characters are equally likely. There are some characters which are used more often than the other one. So, and linguists have worked on it. So, for character recognition, at least we have a priori probability. In some cases we do not, but in most cases we have. So, Bayes formula is quite useful for such cases, but then in many cases we have to use subjective probability where CFs are better. Mycin actually started with the CFs. and which had this statement which we mentioned, like there is a 70% probability that you have malaria and so on and so forth. Here are two examples. One is that in rainy season probability of some specific type of disease like typhoid increases. Now, this is the problem actually. See, the subjective probability is different than objective probability, because the probability, subjective probability not only depends on experts' intuition and judgment, but also changes, varies over a period of time and varies sometimes in location, location dependent as well. So, in rainy season probability of some disease increases, and winter probability of some other disease like swine flu increases. And let us take one more example of the intrusion detection system. When you are talking about an educational system, the academic system, students will actually try to attack. So, you have problems like script kiddies, it is called script kiddies. And if you are talking about a bank website, you have more that are called targeted attacks are more possible. So, point is the probability of attacks taking different context becomes different, which is not the case with probability. Okay. So, there is a rule you can see, if the packet contains source and destination from the same range, the packet is using unknown port number, it has content which is not possible to be decrypted, then there is an 80% conclusive evidence that it is denial of service attack. Okay. So, that is the example of CF, the subjective probability. With that, we will come to an end of this particular module. But before we, as normal, before we conclude, we will talk about, we will revise whatever we have seen in this particular module. The module we started talking about problems with predicate logic, the imprecise information, incomplete information, information which is true sometimes and false at the other times. They are impossible to be represented using predicate logic. There are cases which is related to subjective probability, the cases which is related to objective probability again are harder to be handled using the predicate logic. Whenever such things are required, we require to augment the basic, the primary method of using predicate logic. NMRS is one method that we have looked at, and the other method that we have looked at in this particular module is probability based and the CF based methods for representing knowledge. In the next module, we will be looking at few other methods of representing knowledge, which is difficult to be implemented using predicate logic. With that, we come to an end. Thank you.